Okay, so let's make some serial resistors and parallel resistors here. First, I want to disconnect this junction here. This is for the single unknown resistor. Now I have the two resistors here in my hand. So how do I make a two resistors in series? Well, that's actually pretty easy. I brought some additional wires. Doesn't matter which one starts, which one ends. So this capacitor, excuse me, capacitor. This is two capacitors in series. So the red will be here, the black will be here. Um, so I'll put this in. Sorry about the noise. Okay, let me see if I can still fit everything in the screen. Okay, I can still do that. So, all right, so this is just in the middle, and the red is disconnected and reconnected over to this, and the black is disconnected, reconnected with this. So now the two are in series because there's one wire joining them together. So again, discharge. Yep, there was a little bit of charge, discharge, and then we'll charge up the known capacitor, but we don't really know where to go in terms of the known capacitor. So is it still 5 and the 2 or 5 plus 2 or what, right? So I'll have to try. Maybe it's going to be 7, a 6. Let's do a 7 because I don't know what zero capacitor will do. So I'll do a 7 and then I'll charge up the 7 and wait for some time to reach a 10 volts and then switch over, see if I can hit the 1/2 to 1/3 mark. Ooh, okay, that's a little less than 8 volts. That's 2/3, more than 2/3, right? So the 7 is way too high. And I'm going to discharge everything. Wait for a few moments. And I'm going to change this to, let's see, maybe 4 because that was way too high. Let's go for 4. So we'll charge up the capacitor, known capacitor, wait for 10 volts. So here 10 volts reached. Back here to see if we can discharge to 1/2 to 1/3. Okay, still not there, a little over 7 volts. I'm gonna have to cut major amount down. Okay, so let's keep it here. We'll discharge everything. Okay, everything discharged. So before I start charging back up, I want to decrease to 2. Okay, maybe 2 is good. Why does 5.7 plus 2.25 equal to a 2 or less? Well, it's not necessarily plus, right? Okay, so 10 volts already charged, and this way, oh, okay. It's a little more than 5, so that means I have to decrease to 1, but not before I discharge everything. Wait for full discharge. Decrease to a 1 microfarad, charge up the 1 microfarad, give it a short moment, and then flip to this side. Okay, finally I'm reaching that range. I got a 4.1, roughly 4.1. The needle keeps moving very gently, but 4.1. I use a 1 micro, so I'm just going to discharge it. And I have a table already started. So I'll do a 1 microfarad known, and the other one is 5.69 series, 2.25, and I got I forgot the number. Okay, no trouble. Charge it up again. Wait. Okay, charge the other side. 4.1. Okay, close to 4.15 actually. Let's discharge. I'll say 4.15. 4.5. Okay. So the next one is to do parallel. So how do I do parallel? Well, first I have to disconnect these two red and black double leads. I'll reclaim my capacitors. I'll connect them like this. I'll bring them into the view. So this is parallel. Let me get my webcam here so I can see a bit better. So this is parallel, right? So red to the red and black to the black. And either this red or the other red can connect to that red. Either this black or that black can connect to that black. So now they're parallel, like this is parallel. So I'll have to move my apparatus. Maybe the switch is out of their view, but they're still in there. Okay, my S2 is out of your view, but I'm pressing it down to do a full discharge, right? There's almost nothing there. Okay, so when they're parallel, what about the voltage? Okay, so let's try still with the 1 microfarad. We'll flip to the A side so we can charge up the 1 microfarad, 10. Wait. Okay, 10 already. And back here to see where we hit. Oh, that's really way too low. A little over 1 volt. I said a third to a half. So that will be 3 to 5 volts. Okay, so it looks like 1 micro is less than that. So we discharge by pushing down S2 here. That's this way, right? Out of the view. Then pushing it down, you can hear that. Okay, discharged. And I'll change this to something bigger. I'll do a 4. Charge up the 4 by flipping to the A side and just wait for it. That's good. And flip to the other side and charge the unknown parallel capacitor. Hey, this is good. It's in between a 3.3 and 5 volt. This is roughly 3.9 volts, close to 4. I really don't have the right angle to view it because I gave you all the best angle to view. I'll call it 4 volts. All right. So I'll record this as I used a 4 microfarad known capacitor and 2.25. They're parallel with 5.69. Start with 10 volts and with 4 volts. And it's already discharging slightly to 3.9. Okay, so now I have all the numbers. It doesn't really take a whole lot of time, but wiring does take some efforts to do. So I'll discharge, and now all capacitors have been discharged. I'll switch the power supply off and the experiment. So just one more thing to show you here. Now that everything has ended, right? I have a little bit extra space just to show you again how the capacitors in parallel is connected. So the parallel capacitors are like this, right? So okay, that's a little easier to show, right? So that's parallel. So if I want series, so this will be two capacitors in series, right? They're chained together. In series means the current has to flow through one and then the other, right? So that's in series. And again, this is parallel. Right? Thanks.